Good day everyone, and welcome to another video with Frank Edu Solutions. Today we are going to be looking at Q&A with Frank. So we're going to have a little question and answer with me. Like every of our video comes with a video. Then we have the Q&A, and then lastly we always have the Did you know section. So today is the Q&A with Frank. Today we are going to be looking at solved problems on determinant of matrix, minor and cofactor, adjoint, and inverse of matrices. So basically, we're going to solve a question that's going to contain all these things. I believe if you haven't watched the video on this, please, I'll add the link in the description below. So please do well to go to the link and watch the video. That would help you understand everything we are going to do here today. Now, how do you find the inverse of a 3x3 matrix? Now basically I've explained this in the video, but I'm going to explain it here so that we can actually understand what we're going to be doing. Please note that our subsequent videos from this video are going to be posting on YouTube, we're going to be posting on Instagram, and we're also going to be posting on YouTube. But the previous videos are also going to be available, so we're also posting them on various platforms so that you can easily access, because a lot of people have told me that they prefer accessing it on different platforms than only YouTube. So I'll be spreading it across various platforms so you can follow us in whatever platform you're in. Okay, so how do we find the inverse of a 3x3 matrix? So the first step in finding the inverse is to estimate the determinant of the given matrix, which we learned in our video. Find the transpose. This is optional. Like personally, I'm not going to use this. So personally, I'm going to move this number 2 down, and after I find the determinant of the given matrix, I will calculate the determinant of the 2x2 matrix. Like basically, the 2x2 matrix are the minors of the individual matrices. So we'll take each element in the matrix and find their minors. Minors is well explained in the video we have, although we're going to see it when we start solving. And also we're going to prepare the matrix of cofactors. The cofactors is basically the determinant of the minors included with the sign that comes with them. Please do well to check out our video, like I always say. And lastly, okay, then we're going to, after arranging the matrices of cofactors, we'll now find the transpose of the matrix of cofactors. If you find the transpose earlier before now, then you don't need to find the transpose again. But because we have chosen to skip this number 2 in the initial stage, so when we come down here, we're going to actually find the transpose of matrix of cofactors, and then finally we're going to divide it through by the matrix of the elements, the conjugate of the, or multiply by the we're going to divide through by the determinant of the main element of the main matrix. Now that basically that A inverse is now the transpose of matrix of cofactors will give us the adjoint. So basically we can say is 1 over the determinant of A times the adjoint of A. So let's actually solve a question, and that's what we're here for, and see how it goes. Now, the inverse of a 3x3 matrix. So I put this here so you can remember what we're trying to do, the steps we're trying to take, and this is actually the question. Now, this is our matrix. So first things first, we're going to find the determinant. How do you find the determinant of the matrix? Okay, the first thing will be take the first number, eliminate the rows and column accompanying it. So you have 2. Sorry for the minus, I don't think that's supposed to be there. I think that's an error. So you have 2. Then when you eliminate, you have 1, 1, minus 1, and 2. And then you have in the second column 1. Now 1 is supposed to take a negative sign because it's actually plus, minus, plus. Please, this was noted in the last video. Please do have to watch it. So you have minus 1. Then when you eliminate the row and eliminate the column, you have only 1, 1, 1, 2 remaining, and then plus 1. Eliminate the rows and the column, you have only 1, 1, 1, minus 1, and find the determinants. Meaning, please let's just watch the first video, because all those things I explained in the first video. Find the determinant of each of them. You're going to get 2 plus 1, 2 times 2 plus 1, minus 1 times 1, and 1 times minus. Together this is going to give us 3. So I've been able to find the determinant A for matrix A, and that determinant is 3. And since A is a non-singular matrix, that means A inverse exists. We're going to take is to, I added the matrix here so we can also see the question we are trying to solve and always remember where we are going to. So you can see the matrix there. Now you can see we're going to now be finding the minors and the cofactors. Like I said, the minor is when you eliminate the rows and you eliminate the column of that particular element you are dealing with. The remaining ones are the cofactors. So if you go to 2, eliminate 1 and 1 is going to remain 1 1 and minus 1 and 2. So by the time you find determinants, you get the minor and adding the sign. So the sign goes forth. 2 has plus, the next one has minus, next one has plus, the next one under 2 has minus, the next one has plus, the next one has minus, the one under 1 has plus, the minus one under 1 has minus, and the 2 has plus. So those are the signs that each of them. Okay, so whatever you get as the minor, you add that sign that I have allocated. Please, this was well explained in the first video. Now, the minor of 2, we'll do the same for 1. Eliminate the rows. You have 1 1 and 1 2 remain. Eliminate the rows and column, and then when you get your answer, you add the sign. So with this 2 minus 2 is supposed to be 1. I don't know how these errors are coming in. So the cofactor of 1 is minus 1. Factor of the third one, you can see. So that we were done with the first row, and we'll go to the minor cofactor of second row, and you go through the same process, and we're done. You go to the okay, until we're done with second. Now we're going to be done with second, because second is 1 1 1. So I've done 1. Now we're doing minor of 1 and the cofactor minor of 1, which is minus 10. Cofactor is plus 10. We now go to the third row. You do for 1, do for minus, and you do for the minor of 2. That way we have been able to get numbers. So those numbers are what we're going to place into this matrix. So we have 3 minus 1 minus 2 minus 3 3 0 and 0 minus 1 1, according to how we got them. So basically the cofactor of 2 is 3, cofactor of 1 is minus 1, cofactor of 1 is minus 2, cofactor of the one under 2 is minus 3, the one under 1 is 3, the one under 1 is 3, and the last row 1 is 0, minus 1 is minus 1, and 2 is 1. So we now have the cofactor. Now how do we get the adjoint? Basically, I said earlier that the adjoint is just the transpose, and we explained transpose in the first video. The transpose is basically the adjoint is basically the transpose. You see, transpose is when the rows become the column and the column become the row. So if you look up, we have 3 minus 1 minus 2, that will become our first column, minus 3 3 3 becomes second column, and 0 minus 1 1 becomes the third column, and that way we have formed the adjoint. So now to find the inverse becomes very easy. All we have to do is to divide the adjoint we have by the determinant we got. So the determinant we got was 3, so 1 over 3 times the adjoint that we got, and that gives us the inverse of the matrix. You all enjoyed this video. I've all learned how to solve questions on both cofactors, minors, inverse of matrix, and determinants. I believe it should be easier for us. And please let us like our videos, share, subscribe, and comment how we can improve. And like I said, we're going to be on all social media platforms. We're going to see our videos in any social media platform. You can think of Facebook, WhatsApp, YouTube, Instagram, and TikTok. Thank you for watching, and see you next time. Please watch out for our DG coming out on Monday.